So we're looking at events that have 3 outcomes, which means the diagram is just going to be bigger. The same principles are all still the same, but you're just going to have more diagram to actually construct to start with. So you've got a win, lose or draw situation going on. The probability of winning is 0.5, the probability of drawing is 0.3, so that means the probability of losing is the 2 of those events added together and then taken away from 1. So that leaves you with a probability of losing of 0.2. So we can fill in that missing value. So again, that branch there has to add up to make 1. Well, there's no change in the probabilities between the first game and the second game. There's no psychological going on, so it's just literally going to be copying those numbers over into the diagram. So once the diagram is complete, we can then move on to part B, and I want the probability that they're going to win both games. There's only one way to do that, win-win. So the probability of actually winning both games is going to be 0.5 times 0.5, which is going to be 0.25 or a quarter. And that's it. So once the diagram's completed, you should be able to follow that through as normal. So because we've got to do this again 3 times, so 2 more times, so we've done the first selection, replaced it, and then go again and again. There are shortcuts that we can have instead of having an even bigger frequency tree. Okay, so what I'm going to do is I'm going to use this as a guide, but I'm also going to do my calculations to one side. So what I'm after is the probability of all the same to start with, and then I'm going to do the probability of all different, and then I'll work out the probability of 2 of them being the same by subtracting my 2 answers away from 1. And I'm going to start with the all different. So the probability of getting a black out of 10, probability of getting a red, and then probability of getting a green. Now because it's unconditional, it's nice and straightforward, we can just times them together. So that's going to give me 30 over 1000 for one lot of different answers. Now I can have black, green, red, black, red, green, so that's 2 options there. I can have red, I'll use my pointer, red, black, green, red, green, black, so I've got another 2 options there. Green, black, red, green, red, black, and then I can't go that way. So I've got 6 ways of doing them, when they're all different probabilities, so that's going to give me 180 over the 1000. So that's probability of them all different. Now the probability of them all being black, all black, put all in there, is going to be 3 times 3 times 3, 27 over 1000. The probability of them all being red is going to be 25 times 5 is 125. And then the probability of them all being green, slightly, is going to be 8 over 1000. So I've got my different answers so far. So all different, all black, all red, all green. So what's left is 2 of a kind. So you're going to do 1, take away those 4 answers, So the probability of having two exactly the same is going to be 660 over 1,000, which of course you can cancel if you so desired. So it is quite a complex question, and how you set it out is completely up to you. And there isn't other ways of answering the question. You can work out each branch and have a huge diagram instead, and it's just making sure that you follow that through so you can see the different steps of working out. So just be careful as you set out your next question. So I'm going to give you a chance to have a go at that kind of question. So I've started off the tree diagram. You will have to finish it for the last branch. You've got the same situation with the beads. Simon's going to take it out and then replace. And he's going to do it 3 times in total. So like I said, you're going to have to extend that tree. And then think about the amount of working out that I did. So you're going to have to repeat that process. Okay, so I'd like to pause the video and then have a go, please. So we start by constructing your diagram just to help you with the outline of the working out. The probability of all the same is what you're going to start with. So the probability of blacks, probability of reds and greens. You're going to work those out to start with, and then the probability of them all different. And remember, there are 6 ways of doing that. Okay. So as you carry on through the working out, hopefully you agree with what I've got. So the probability of getting all blacks is 64 over the 2,197. All reds is 512. All greens is 1. All over the same denominator. All different, and there's 6 lots of getting it all different. Gives you the same value and then 6 times, and then you're going to subtract it from 1. So your final answer is 1,428 over the 197. So that's the quickest way to do it. It's not the only way to do it, but it is certainly quicker. So because these do take a long time to do, there are 2 questions. The top one is very similar to what we've just been doing. The numbers are obviously a little bit different, but you get the process and you just repeat that process from the last example. The second one is very similar to the very first question we looked at, where you've got a win, lose or draw scenario and you want to win exactly 1 game. So complete at least one of those, hopefully both of them, but they are challenging questions for you to have a go at. So pause the video and have a go. So the answers are on your screen, so you can check to make sure you're happy with them, and your teacher will check your working out because there will be a lot of it. Well done, it's a hard task.